Everybody, now we are going to see conventional and solid state speed control of AC drives. A three-phase induction motor is practically a constant speed motor, just like a DC shunt motor. The speed of DC shunt motor can be adjusted between wide range with good efficiency and speed regulation by shunt field regulators. But in induction motor, speed cannot be changed without losing efficiency and good speed regulation. So we know that induction motor speed n equal to ns 1 minus s equal to 120 f by p 1 minus s. We had been seen earlier videos. It is clear that the speed of the induction motor can be changed either by changing its synchronous speed n or by changing the slip s. The synchronous speed is given by ns equal to 120 f by p. By varying f and p, speed can be controlled. Then we have to move with torque produced by three-phase induction motor is T proportional to E2 square proportional V square. Okay, this is basic concept of speed control of three-phase induction motor. Next, we have to consider what are the controlling component, main controlling component is there in three-phase induction motor. That controlling component are stator side and rotor side. Stator side or by changing the applied voltage, then by changing the applied frequency, by changing the number of stator poles, voltage by frequency control. Those all are classification under the control of stator side. And next, rotor side is rotor rheostatic control by operating two motor in cascade by injection of an EMF in the rotor circuit, slip power recovery control. So these are in rotor side control. So by those activities controlled in the various controlling mode in stator side, that is stator voltage control, stator frequency control, V by F control, pole changing method. In rotor side, adding external resistance in the rotor circuit, cascade control, slip power recovery scheme. These are very important classifications, controlling classifications. So stator side control always using transformer by controlling all the main component. Then primary resistors connected in series with the stator winding. This is using auto transformer by control the stator changing applied voltage. This is the easiest and most economical because this method is very rarely used due to the following reason. That reason or a large change in voltage is required even for a small change in speed. This large change in voltage will result in a larger change in flux density also. It will disturb the magnetic conditions of motor, thereby affecting the performance of motor. Based on some approximate relationship at low slip values, the following equations can be written. That equations are I2, that means secondary current is always can have slip and voltage by a secondary resistance, that means I2 equal to SBR2. Now let us see using transformer of three-phase induction motor. It is commonly used method for ceiling fans driven by single-phase induction motor which have large standstill impedance limiting the current drawn by the stator, where this is primary resistor connected in series with the stator winding. That primary resistor always used for some special occasion of applications. This is graphical representation. It meant frequency manipulation appears to be an effective method for speed control. that require a simple DC to AC converter with variable switching intervals by means of solid state control. That control method, the frequency of the stator voltage and poles can vary depending on the increase in the load speed, that means synchronous speed, a decrease in the maximum torque, a decrease in the starting torque, an increase in speed at the maximum torque, a decrease in the starting current. Those 5 categories mentioned by on this graph. Change in stator frequency. The stator frequency represent synchronous speed equal to 120 F by P. F is supply frequency, P is number of poles. And those representation we pick the frequency. F is the stator voltage frequency, P is the number of poles. Already I told, since then synchronous speed is directly proportional to the frequency of the stator voltage, any change in frequency results equivalently motor speed also change. Change in stator frequency. The stator frequency easily applicable to squirrel cage motor because the squirrel cage motor adapts itself to any number of stator poles. So the change of number of poles is achieved by having 2 or more entirely independent stator winding in the same slot of stator core. So the various limitations of this method are only step change in speed is possible, no smooth variation of speed. Second one is high cost of the motor. Third one is design complexity. This is voltage frequency control method. In this voltage frequency control method is most common method by using the various applications. Here one or two solid state switches are implemented by using this controlling activities. That advanced switch version or rectifier and inverter. Rectifier function is which is converted the received fixed AC into DC. Inverter enter the input of DC into proper AC. Those two functions are processing across this controlling limitations by control voltage and frequency. Next is speed or characteristics by V, that means voltage by frequency method. This method graphical representation or already I said an increase in the load speed. One is increase in the load speed. Second is a decrease in the maximum torque. Third is decrease in the starting torque. Next, changing the number of poles. So this is very important and essential for this classifications and explanations. Synchronous speed always depends frequency and inversely proportional to poles, number of poles. This is pole connected diagram. This method has been used for elevator motor, traction motor and also for small motor driving machine tools. The change of number of poles is achieved by having 2 or more entirely independent stator windings in the same slot of stator core. Each winding gives us different number of poles and hence different synchronous speeds. Motor with 4 independent stator winding are also in use and they give 4 different synchronous speed. This is pole changing or pole connected differentiation. Come, let's go with some interesting another topic of rotor side control. This method is similar to the armature resistance control method applied to DC shunt motor. This method is applicable to slip ring induction motors alone. and the speed is varied by some external into the rotor resistance. It has already discussed for small slip value T proportional to, that means torque proportional to slip by secondary resistance R2. Therefore, for the constant torque given, slip can be increased. Okay. Rotor side control also having three important classification, that are cascade control, rotor resistance control, slip power recovery scheme. Those three main classifications can have some sub-classification. That classifications are Kramer system, conventional system, static method. Scabious system can produce two classification: conventional method, static method. Come, let's go with cascade control. When multiple speed are required, motors are sometimes operated in tandem or in cascade mode. In this mode, two motors are coupled to the same shaft. Look at the picture. The two motors coupled to the same shaft. The stator winding of the first main motor is connected to the mains in the usual way, while that of second stator is fed from the rotor winding of the first. Then the first motor necessarily be of slip ring motor, and the second one may be either squirrel cage motor or slip ring motor. Okay, good. The motors may be so connected that both tend to run in the same direction, or the phase rotation of one motor may be reversed, thus tending it to make it rotate in the reverse direction. The first case is called as cumulative cascade, and the second case is called as differential cascade. So, we have two cascade in this cascade operation. One is cumulative cascade and another one is differential cascade. If P1 and P2 are not equal, 4 synchronous speed are possible, 2 with tandem operation and 1 for each motor separately. The motor connection let the two machine M1 and M2 run with slip of S1 and S2 respectively. So, we just calculate speed in RPM of M1 is N1. So, come to the conclusion of main motor alone, then auxiliary motor alone, cumulative cascade connection, differential cascade connection. This is concluded derived formula from the above operation of cascade connection, that main motor alone can get Ns equal to 120 F by P1, auxiliary motor alone Ns equal to 120 F by P2, cumulative cascade connection N equal to 120 F by P1 plus P2. This is the main difference of those three different speed. Differential cascade connection are N equal to 120 F by P1 minus P2. Note, always P2 less than P1. It has some disadvantages. That disadvantages are, this method requires two motors, more expensive. Speed control is not possible. It cannot be operated when P1 equal to P2 or P1 less than P2. Thank you.